So in this video we're going over the AQA additional physics topic of gravitational potential energy. And in some ways this is an extension to the video in which we talked about falling. So on Earth we realised that gravity is a force which acts on all objects, and it's a force which is coming from the Earth. So when you're on the centre of the Earth, gravity is balanced by a reactionary force from the ground. But when you're above the Earth's surface, you're not being balanced by this reactionary force. Let's say you're standing on a ledge. If you were to stand off the ledge, you would fall, which means that you have potential energy inside you, or any object which is on a ledge or above the Earth's surface. Because it has this potential to fall, it would be a transfer of energy from gravitational potential energy to kinetic energy, which is how I think about it being a potential energy. All objects above the Earth have a potential to fall, and if they do, they will fall with a lot of kinetic energy. Therefore, gravitational potential energy is affected by the height of the object from the surface, because if you were to drop a book from, let's say, the top of a very tall building, it would reach its terminal velocity, which we talked about in the previous video, and this would mean that it would fall with a very high kinetic energy. Whereas if you were to drop it from, let's say, a ledge, it wouldn't reach its terminal velocity, and so it wouldn't be moving as fast, so it wouldn't have as much gravitational potential energy or stored energy. But we also talked about in the previous video about falling the effect of mass, because the higher mass means it moves faster before it reaches terminal velocity. So if this something has a higher mass, it's going to fall at a faster speed and therefore has more potential to release this kinetic energy, and so has a higher gravitational potential energy. So we need to think about the height, the mass, and gravity when doing questions about gravitational potential energy. And this is factored into the calculation which involve gravitational potential energy. So here we have our equation, and I'm going to talk through each term. So EP is the change in gravitational potential energy. So when I say change, I'm talking about if we were to move something from one ledge to a higher ledge, or if something was to fall and eventually it would hit the ground and would no longer have gravitational potential energy. But EP, when you're doing these questions, you're looking for a change in gravitational potential energy. M is the mass. Remember I said that the mass was important, and it is measured in kilograms. By the way, the gravitational potential energy is measured in joules. G is the gravitational field strength in newtons. And as most of the questions will be set on Earth, it normally is a value of 10 newtons, because that is the gravitational field strength of Earth. But let's say we were dropping something on a planet with a higher gravitational field strength, well, the change in gravitational potential energy would be different. And finally, H is the height in meters. And we need to think about all of these when we're doing a question. So here is an example of a question. A person with a mass of 90,000 grams is taken by an elevator from a height of 15 meters to a height of 55 meters. Assuming the gravitational field strength of Earth is 10 newtons per kilogram, what is the change in gravitational potential energy of the person? Well, although this question is wordier than some of the ones that we've tackled in the past, it's good to carry out the same method in looking at the units. So let's go back to our equation here. We're looking for the change in gravitational potential energy. We have been given a mass, we have been given the gravitational field strength of Earth, and we have been given the height. So in this question, there's two things we need to consider before we start banging numbers in. Firstly, the weight of the person is in grams, but we want it in kilograms. So it's a simple conversion. 90,000 grams divided by 1,000 equals 90 kilograms. And also, we are looking for a change in height. So we need to find out how much they have been lifted up. So we are doing 55 meters subtracted by 15 meters equals 40. So as we're looking for a change in gravitational potential energy, we also need to think about the change in height. So the change in height has been 40 meters. So our equation is pretty simple. We've got our field strength of Earth, that's in the correct unit. We now have our mass in the correct unit, and we have our height. So the equation, when you put numbers in, is 90 times 10 times 40, which equals 36,000 joules. I hope this video was helpful. Thank you.